To start this video, I will first introduce two main concepts, force and free body diagram. What is force? Force is a push or pull that has both magnitude and direction, which means it is a vector quantity. What is free body diagram? Free body diagram is a technique used to show all the external forces acting on a body. The body is represented by a single isolated point or free body, and we only depict those forces that are acting on the body externally. But what about the internal forces? Why not show them in free body diagram? Because we are only interested in the forces that would make the body move. Internal forces do not affect the motion, therefore we ignore them. In 1687, Sir Isaac Newton introduced his famous 3 laws of motion. I will go into each of these laws in depth, but first, let's have a quick overview. First law, or law of inertia, says an object remains at rest or in uniform motion unless acted upon by an external force. The second law says the force acting on an object equals its mass times its acceleration, or F is equal to ma. And the third law says for every action there is an equal and opposite reaction. These laws help us understand everything from falling apples to planetary orbits. So now let's get into the first law of motion, or law of inertia. We all have experienced that if an object is at rest and we just leave it alone, it will remain at rest. And if an object is moving with constant velocity and there is nothing, absolutely nothing, affecting its motion, not even friction, the object remains in motion at its constant velocity. This is the first law of motion. As I said before, the other name for the first law of motion is law of inertia. But what is inertia? The property of a body to remain at rest or to remain in motion with constant velocity is called inertia. Some objects have more inertia than others. For example, a big mattress is harder to move from rest than, for example, a small pillow. What is the difference between a mattress and a pillow that would cause one of them to have more inertia? The answer is mass. The inertia of an object is measured by its mass. What is mass? Mass is a measure of the amount of matter in something. Mass is different than weight. Weight is mass multiplied by gravitational acceleration. So weight varies by where an object is located. But the mass is the same everywhere, on Earth, on the moon, or any other planet. Newton's second law of motion is closely related to Newton's first law of motion. It mathematically states the cause and effect relationship between force and changes in motion. The second law says F is equal to ma. But why is force proportional to acceleration? We know that when we apply a force on an object, the motion of that object changes. And when we say the motion of the object changes, what we really mean is that the velocity changes. And we know that a change in velocity by definition is an acceleration. So this means the total external force is proportional to acceleration. We also know that the larger the mass of an object, the bigger force it needs to move with the same acceleration. Or in other words, if we apply the same force to two objects, one with a larger mass than the other, the object with the larger mass will have a smaller acceleration. So acceleration is inversely proportional to mass. It has been found through experiments that the acceleration of an object depends only on the net external force and the mass of the object. So, combining the two proportionalities I just explained, we can write down Newton's second law of motion, or F is equal to ma. As I have mentioned before, in F equal to ma, we are only interested in the external forces on the system. So when solving a problem, we need to carefully determine the boundaries of the system and find only the forces that are external to that system and ignore the internal forces. For every action, there is a reaction is not just a life lesson. The Newton's third law of motion describes a symmetry in forces. Have you ever punched something or somebody? You might have experienced that as much as you might hurt the other object or person, your hand also feels that force. This is because forces always occur in pairs, and one body cannot exert a force on another without experiencing a force itself. You can also experience this if you push a wall. An and it feels like the wall is pushing you back. Or if you jump onto the floor, you exert a force on the floor, but you also experience that force in your legs. These all prove Newton's third law of motion. Whenever a body exerts a force on a second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. I hope this video helped you understand the concept of forces and the Newton's laws of motion. If you have any questions, ask me in the comments, and don't forget to subscribe so you don't miss my next video on normal, tension, and other examples of forces.